Okay, an optional question. Again, the point of it is taking options, you get better options in life. And they want me to verify this identity over here. It looks kind of difficult. What I'd recommend you do initially is just simply rewrite it. So rewrite it. And using summation notation. That's why it's in this section of the notes, by the way. So you're going to be using this notation over here. All right? Let's take a look at that. And part of this is just going to be working through the K. All right, so the first thing I just talk about this guy right over here and communicate to you what this means to me. This means the sum from 0 to n, where the counter variable is j. So it would be sine 0 plus sine 1. These are integers, plus yada, yada, yada. And where would you stop? You'd stop at n, which is sine of n. Is that what you wanted? It is. Now you should notice that this thing is just identical to what's on top, except it's a cosine. All right? Next thing I'm going to do is it's far more difficult. All right, so let me erase this over here. This is far more difficult, the next step. All right? So this is the easy part. This was easy, just rewriting it. Here comes the tough part. And it also might be, what's the motivation for this? To try to simplify it. All right? So I divided into two cases. The first case I divided into is n even. And I wrote the sum. I wrote this sum over here as this. Now, what I want to do, I just want to verify it's true, all right? So let's just verify it's true. How are we going to do that? Well, I'm going to rewrite it. And I'm going to start with one thing at a time. I'm going to start with this first. And what would you get? You would get sine. Well, let's see, if j is 0, you get sine of n. And then you're going to get sine of n minus 1. And I'm going to say yada, yada, yada. And these are additions. And we're going to stop at that, the sine. Well, that's going to be n minus n over 2 now. All right, I'm going to simplify that, though, and because it just doesn't look right to me. N minus n over 2 is just going to be n over 2. I'll put that down for you. All right, now I'm going to do this guy, and let's write it down. Let's start. What are you going to get? Well, you can get plus sine 0. Then you get sine of 1. Oh boy, yada, yada, yada. And then when you can eventually get the sine of n over 2. Well, what I notice right here, I got them all, but my problem is I've got one too many of these, and that's why I took it away. All right? So let me erase this work. I'm pretty convinced that that's true. And since I did this one, I basically got this one done too. All right, really the same thing, except they're using the cosine symbol to the sine symbol. The next thing I do is, I want to look at when the case is odd. All right, so let's do that when it's odd. Does it look any different? It does. And let's write this down for you. And again, what I'm trying to do is I'm trying to verify this. All right, let's just write it down. Now, look, it looks different than the other one, no, doesn't it? Let's write this down. So what are you going to get? I'm going to start with this one first. So it's going to be sine of n minus 1. These are additions, yada, yada, yada. The last one I'd write down is, let's write this down. It's going to be sine. Well, let's see. It's going to be n minus 1 over 2. I'm going to simplify that, though. You would get 2n over 2. And this is always a problematic for almost everyone, by the way. So it's going to be minus n plus 1. And what would that give you? Well, that would give you n plus 1 over 2. Let me erase. And write that down. All right, let's talk about this guy over here now. And what are you going to get? Let's write this down. You're going to get plus, well, we're starting at 0, so it's going to be sine of 0. Then it's going to be sine of 1. And then yada, yada, yada. I'm going to get to the n guy, and what's that going to be? Sine of n minus 1 over 2. Well, I hope you realize that, this is, it's covering everything, all right? Certainly it starts at n, stops at 0, and these two guys over here, again, is odd. I'll give you an example. Let's say n were, I don't know, let's say it's 51. What would you get over there? You get 51 plus 1, 52, 26. So you get sine of 26. And what would you get for the next one? It should be 27, right? Well, 51 minus 1 is, 25. I'm sorry, not 27. The one before has 27. This would be the sine of 50 over 2, which is sine of 25. So it works out fine. So these are good, right? These are all good. let me start to erase, and I got these sum formulas down. But again, if you don't know why you're doing that, it's almost pointless to get there. But there's a point to this. And I want to go to the next step. And the point of this is we're going to use formulas to rewrite these write these summations. And this is the form we're going to be using over here. Now, what is this? It's called the product of sum formula. You've derived this way back earlier on in the semester when we did basic identities. So what I want to do is I'm going to point out we're really trying to rewrite this guy over here. All right, that's what we're trying to do, rewrite this guy. And I'm seeing this thing, and if this looked like anything, I want to say that the a plus b, a minus b, we're looking at these things over here. All right, let me write this down. So I'm going to write down, let me write down a plus b is equal to, well, I'm going to say j this time, and then I'm going to say a minus b is going to be equal to the n minus j. Well, I'm going to add those two together, and what would you get? You would get 2a equals n, or a would equal n over 2. All right? So, I know what the a is now. Do I know what the b is? Well, let's write this down. If a is n over 2, what's b? I don't know. Let's figure it out. The b would equal j minus n over 2. All right? So what I do is I just write it down. Oh, you know what? I did something different than notes, so I'm gonna go back over that though. I don't want to. We could do that, but I'm just gonna back over it. I'll back this up. I noticed I did something different. Not gonna change it much though. And then this would be j. Sorry about that. Let's add it together. What do you get? 2a equals n, and the a is going to be n over 2. Let's do the b, and I'm using a formula. So what do you get over here? You get n over 2 plus b equals n minus j. And what do you get there? You'd get, what's b going to be equal to? It would be n over 2 minus j. All right? So that's what I'm writing down over here. So it's going to be 2 sine n over 2. That's what the a is. And the b is n over 2 minus j. All right? So I'm going to get my eraser out again, and I'm pretty comfortable with what I got over here. And I'm starting to notice something about this sum. And this sum over here, this thing has nothing to do with j. So what I do is I pull it out. And I get this over here. And it's really kind of like a simple thing. Next thing I do is I notice that the two terms, those two terms have something in common. I'm going to say minus sine n over 2. What would you left off with? 1 minus 2 times the sum, that cosine n minus 2 over j. So I'm comfortable with this. This is good. All right? Then I'm going to do the next guy. And again, what am I doing? I'm using this again. All right? And we just did that, right? So it just rewriting the same way. I mean, it's not going to be any different. The only difference now is it's cosine instead of a sine. And let's do it, all right? So what do we get over here? I'm going to say n minus j equals a plus b. And a minus b is equal to j. Add these together, you get n equals 2a. So a is n over 2. Deja vu all over again. And then what's the b going to be? Well, let's write this down. So let's take a look. You would get j equals a, which is n over 2, minus b. So the b would equal n over 2 minus j. And that's where these things are coming from here. Whoops, sorry about that. All right. What do I notice now? Again, it's really the same thing, that this guy here can be pulled out. All right, so I pull it out. So we have two things, and these are important things. And I'm going to circle them for you now. I know this is equal to this. By the way, I just factored that just like I did before. And I know this is equal to this. But what do I really want to know? I want to know the ratio. So I write it down. We're going to look at the ratio now. We're going to take this guy. Let's remind you, that's right over there. I just write it down. And I want this guy over here. I just write it down. What's nice about this, though, whatever these things are, they cancel off. They're non-zero, by the way. All right? They're gone. Then we left off with something pretty simple. Left with this. What's this reduced to? This. So we just did the odd case. Was that odd? I can't remember. Oh, that was even. I'm sorry. Yeah, that was even case. We just did the even. Now we're going to do the odd case. Almost the same thing. All right? So we're going to do n is odd. And since we just did it, I think it's going to be a little bit easier to do this time because we just did it. All right? So we have the sum. We did this before. We have this sum. We do the same thing with the product of sum formulas. We get these things over here. And then we do is just take the ratio. That's all we've done. Same thing we did before. We're getting faster at it. We get this over here. What happens? Cancellations. You left off with something pretty simple. And you get this thing over here. And this was for the, again, I hate to say it's the odd case. So we showed what we need to show. And now we know. Well, again, it seems like a strange identity to me, but we know this. This is known. This is true for all n, okay? Integer n. Thank you.